Hello, I'm Aliyah from NG Discovery Media. Today, we're diving into the heart of the industry powering our future, solar panel manufacturing. In this masterclass, we'll see every step from quartz rock to finished module, and even the financial benefits of this sector. It all starts underground. Silicon, the second most abundant element on Earth, is extracted as quartz rock of exceptional purity. These rocks are crushed and purified to obtain metallurgical-grade silicon, the first step toward clean energy. The silicon must then be purified to 99.9999%. This complex chemical process transforms raw metal into ultra-pure polysilicon. This polysilicon is the heart of every solar cell. Without this extreme purity, panel efficiency would plummet. In giant furnaces, polysilicon is melted. A seed crystal is then introduced to grow a monocrystalline ingot. This ingot is a marvel of engineering. Its perfect atomic structure will allow electrons to flow freely to create current. Once cooled, the ingot is shaped and squared to maximize space on the surface of the future solar panel. Diamond wire saws cut the ingot into precise blocks, ready to be sliced into thousands of ultra-thin wafers. This is the most delicate step. Each wafer is less than 200 micrometers thick, barely more than a human hair. These wafers are collected, chemically cleaned, and inspected. They are now the base upon which we will build the cell. To capture more light, wafers undergo chemical texturing that creates millions of tiny pyramids on their surface. This change in texture reduces reflection, forcing light to stay inside the cell to be converted into electricity. Next, we introduce phosphorus at high temperature. This is doping, which creates the p-n junction necessary for electric current. Temperature control is vital. A single degree of deviation and the cell's efficiency could be compromised. The etching step removes unwanted doping on the edges to prevent internal short circuits. Precision is down to the millimeter. A final rinse with deionized water ensures no chemical residue remains on the high-tech surface. To provide that characteristic blue color, we apply an anti-reflective coating made of silicon nitride. This coating traps photons, drastically increasing the amount of energy the cell can produce. It's time to create the electrical contacts. High-precision printers deposit silver paste to form the collection grids. These lines capture electrons and route them to the main circuits of the future solar panel. The cells pass through an ultra-fast firing furnace to fuse the metal contacts with the silicon. This is the birth of the cell. In seconds, the silver paste turns into a solid conductor, ready to transmit energy from the sun. Each cell is tested individually. We simulate the sun to measure its exact power and efficiency. The cells are sorted based on their yield. Only the best will be used in our high-quality panels. Cell manufacturing is complete. But before we assemble them, let's talk about a subject that interests you: the economics of this industry. The initial investment varies greatly. A small local unit starts at $5 million, while a Giga-factory exceeds $500 million. Annual net profit can reach 25%, driven by unprecedented global demand. Note, this is not financial advice. For developing countries, these factories create thousands of jobs and sustainable energy independence. It is the industry of the future. Let's head back to assembly. The cells are connected in series by tinned copper ribbons, creating strings of cells. These strings are the electric skeleton of the panel. They must be perfectly aligned to avoid any power loss. Final assembly, or layup, begins with a layer of ultra-strong tempered solar glass, capable of withstanding hail and storms. We add a layer of EVA, an encapsulant film that will protect the cells against moisture and mechanical shock. The cell strings are placed on the EVA. Each cell is spaced only a few millimeters apart to maximize energy density. A second layer of EVA and a white back sheet come in to seal everything. The panel is ready for fusion. The panel enters a vacuum laminator. At 150 degrees, the EVA melts and becomes transparent, hermetically encapsulating the cells. This process ensures the panel can produce energy for 25 to 30 years, even in the most hostile environments. As it exits, the panel is a solid and unified structure. It is time for finishing and structural protection. The edges are precisely trimmed to allow for the installation of the aluminum frame that will provide the panel's rigidity. Every millimeter is checked. In a modern factory, quality is ensured by a combination of AI and human expertise. Anodized aluminum is pressed onto the edges with a special sealant. This protects the glass and facilitates rooftop installation. The frame is the panel's backbone. It must resist high winds and the weight of snow for decades. We're now installing the junction box. This is where the electrical cables are connected to extract the energy. The box is sealed with a protective resin to be totally waterproof. Water will never be able to penetrate the electrical circuits. This is the final power test. We flash the panel with intense light to determine its exact power class. Each panel receives a unique identification label with its actual performance measured in the lab. To detect potential defects invisible to the naked eye, we use electroluminescence imaging. The panel glows under the effect of the current. It's like an X-ray. We check that no micro cracks appeared during assembly or lamination. The high pot test guarantees electrical safety. We inject a high voltage to check that the frame is perfectly isolated from the circuits. Safety is our top priority. No panel leaves the factory without passing these rigorous international safety tests. The panels are cleaned one last time. They must be spotless for maximum light absorption from day one. We apply the brand labels and QR codes. Each panel is traceable throughout its life, from the factory to the solar field. Packaging is automated. Robotic arms carefully stack the panels, separated by protective foam to prevent scratches. Once the pallet is full, it is strapped and wrapped for transport. These panels are ready for a journey of thousands of kilometers. Our smart warehouse manages thousands of modules. Logistics flow is AI optimized to meet global demand. Autonomous vehicles move heavy loads without human intervention, increasing factory safety and efficiency. The loading docks are buzzing with activity. Containers leave every hour for Europe, North America, and Asia. These panels will power homes, factories, and entire cities, reducing our carbon footprint day after day. The final result is here. Thousands of our panels working together to transform light into life and progress. It's the victory of technology over fossil fuels, a clean, efficient, and profitable future for all. And that's it. You now know exactly how modern solar panels are made, step by step. Thank you for joining us on NG Discovery Media. Don't forget to like and subscribe for more industrial documentaries. See you soon.